Well, hi there. This is Mr. Seidel, and in today's lesson, we have a problem up on the board here, and we're gonna solve it. All right. Now, let me read the problem out, and we'll figure out what we need to do in order to solve this problem. This is going to be video lecture number 12 for Algebra 2. So here we go. Suppose Bob has been working at Shawnee State Forest for 5 years. His first year's salary was $42,000. Each year after his first year, his salary increases 4%. And what we want to be able to do is determine the sum of Bob's first 5 years of service. Okay? So I'm going to write some facts about, facts that we need to know before we solve this problem. So I'm going to adjust this camera here. Woo. So awesome. All right. So basic facts. I'm going to use red. All right, what we are dealing with is a geometric series. Okay, what that means is there's a pattern that happens from the first term. Okay, we could calculate all his first 5 years of salaries and have a pattern, and then if you recall back to sequences, we can find the next term after that, the next term after that. But with this being a series, the reason it's called a series is because we're looking for a sum. Okay? So it's not necessarily a sequence, it's a series of a sequence. Okay? Now, what we're going to do is I'm going to state a fact. Okay? Here's your fact. To find the sum of a geometric series, okay, we need to know the initial term of the sequence so I'm going to underline that, the initial term. Okay, we need to know the common ratio. Okay, and the common ratio, guys, is basically what is the pattern? What's it increasing by? What's it decreasing by? Stuff like that. Okay, and we need to know and n, which this represents how many terms are we adding together. Starting with the first. Okay? So hopefully you can read that. Okay? Yeah, you can read that. All right, so let's define this. I'm going to erase the problem. You can always rewind, go back. Okay. Let's define this formula. Okay. I'm going to go green here. All right, so the definition, the formula, okay, I should say formula here, is what we would use to create or to find the sum of all the numbers in a sequence. So if you're given the sequence, let's go 1, 3, 9, 27, and 81. Okay, those are my first 5 terms in the sequence. All right, now this is a geometric sequence. Why is that? Because this number and this number, yeah, I could add 2, but I'm multiplying 3. 3 times 3 is 9. 9 times 3 is 27. Okay? So the pattern is geometric because we're multiplying by a number. That's what makes it geometric. Okay? So the times 3, that is my common ratio. Okay? What are we increasing by? Well, we're tripling the number, the previous term in that sequence. So if I wanted to find this, times it by 3. But what we're trying to do is we're trying to find the sum of all those numbers. So if I look at the first 5 numbers in this sequence, which is not the problem, but what I'd have to do is, well, just add them all up. Well, that's an easy sequence to look at. You know, our problem, we didn't know the second term. We didn't know the third term. We didn't know the fourth term. We didn't know the fifth term. The only thing that we had was our initial term. Okay, and they gave us enough information of what it increased by. So I'd have to know my ratio, which is R, and that example I just given you, I'd have to know it would be times by 3. Okay, you have to be given that. Okay, I'm going to label this initial term as a sub 1. Okay, hopefully you can see the a sub 1 there. All right, now n is going to represent how many terms are we adding up from the initial term? Well, in this case, it would have been 5. All right, and then the last one we're looking at, this kind of forms the formula S sub n. Okay, that represents the sum of all the n terms. Okay, whatever n is, it's going to represent the sum of those first 5 terms or first n terms of that sequence. Okay, now let's apply this to our problem at hand. Bob's salary. We have to know these parameters. Now the formula, the definition, it's not easy. Okay, it's not easy, but S of n, we're going to write it in this box. S sub n equals A1 times 1 minus r to the n power over 1 minus r. Okay, that is the formula to find a sum in a geometric series. All right, and make sure you pause it if you need to. All right. Now, to use this formula, I have to be given all those things. Well, how many years of service did Bob put in? Okay? Well, he's put in 5. Or we're even looking for 5. What's the total of all his salaries going to be in the first 5 years? Okay? Well, I'm going to write 5. Now the rate, if you remember, it increased 4% from his previous salary. Well, what's that mean? I can't write a rate of just 0.04. I'm writing a percent as a decimal. Well, if I start adding 4% of the salaries, I'm not adding the previous salary to that. We need to make that 104% or 1.04. Okay? What was his initial salary, his first year salary? It was $42,000. Okay? Now this S sub n is going to represent S sub 5. That's going to represent the sum of his first 5 years. Okay? Now I'm going to erase and replace. All right. Time to get it done. Now this part's all plug and chug. All right. So I'm using that formula. And I'll try to keep both in the camera. All right. Now, so that's our formula. All right. Now, well, if I follow that formula, okay, I'll have this. S sub 5 equals 42,000. Notice I'm plug and chug, putting stuff in parentheses because when you use a calculator, it's much easier to input that. Now there's going to be a catch with this section here because I got 1 minus r to the n power. All right, that causes a little bit of problems. So I'm going to take 1 minus, my r was 1.04, and then I'm going to raise that to my nth power, which is 5, over 1 minus r is 1.04. Okay? Now let's simplify. Alright? Now the top, when I punch it in the way it is right now, what I'm going to get is approximately this, negative 9,099.42. Looks a little crazy. Over negative 0.04. I just subtracted 1 minus 1.04. Okay, we're in PEMDAS mode now, solving an equation. I ain't really solving an equation, just getting it done. Now that equals, okay, when I divide, I get 227,000. I got my cheat sheet here, I already done this problem. $485.55. Okay, that is the sum of his first 5 salaries. Okay, now, what's going to happen? I need to shave. That's what needs to happen. But anyway, all right, what we're going to do is we're going to take that, all right, and see if you can figure this out. All right, let's say that Bob started off with 42,000, and each year after that, he gets a 4% increase from his previous salary. Okay, now it's not always going to be 4% of his initial salary, because guess what? Each year after his initial salary is going to be greater. Okay, so then you got to take 4% of that. Now you could use the percent formula and write them all out, but I'm telling you, this formula, when it's a geometric series, you can find the sum of n terms. Okay, now here's what I want you to try to do. All right. How many years would it take for Bob to exceed $1 million later?